think this is good. All right, guys, let's get started. And sorry for this few minutes delay. Currently, I have to operate 3 systems at the same time: my Mac, my desktop, my iPad to get it going with Zoom, sharing screen, recording everything. So apologize for the few minutes delay. Do some house cleaning thing first. And of course, this is sharing that, which is not something I want to share. Very weird again. Okay. Homeworks. Have you guys submitted all the homeworks? Everybody happy with your write-up? No format issues? Okay, confident? All right, okay. So I'm just gonna grade as they are, okay? No problem, no problem. And also now, first exam is gonna happen somewhere between spring break. We just started, but I think we'll finish on time. That means that we'll cover the flexure design and then we'll get into the first exam. I think right now it's actually a good timing for you to start review stuff. When I say that is I start going back to the lecture 0 and lecture 1, 2, 3, just get the PowerPoint ready. That is chapter 1, 3 about concrete properties, and know that. And the other thing is that we'll start doing some practices on Thursday. And we have meeting this Thursday, all right? We have meetings this Thursday, 2 mini series. I try to make it short and sweet, but you know me, I might drag it, okay? So that's where we're at right now. And before everything, let me just try to get this projector working. Somehow they suppressed my HDMI, so I can now show HDMI again. Fabulous, right? So 1 second. Okay, and let me see if I can do that. Sorry, just a lot of things. Just next time I'll probably be here half an hour early to get everything situated. Apologize for that. I thought 15 minutes enough, not enough early. And let me see if I can get this thing working. Is that ever on? Was it on at all? Was on, right? Okay. See what's going on here. Okay, this is so good. See if I can manually turn it on. Okay. Supposed to detect my laptop automatically. Doesn't seem to do that, so I'm just gonna pump in. Chinese magic work? No? Yeah, sure. Fabulous. Okay. Nothing? Nothing here? Anything? Something? Come on, show up. All right. Okay, finally, we're in business. Okay. What we learned from last time was 2 days ago, is it? Should be fresh. What did we learn? Well, I don't know. Flexure strength, moment resistance. But what do we learn? There are 2 things in concrete design, reinforced concrete. What are those? Concrete and steel, right? And concrete is good for what? Compression. Steel is good for what? So you have compression force and steel force, right? Tension force, right? They balance each other, right? So how do you compute tension force? 4 number, 9 bars, 4 inch square, grade 60, right? How much tension force you have? 4 inch square, let me say it again, and 60 KSI, yield strength. How much tension force you have in the section? 240 kips. How do you get that? AS, FY, is that right? Good. Now that's tension. How about compression? How about compression? And that's not on your phone. How about compression? What we use? Nonlinear curve, the nasty, parabolic shapes and trying to find the centroid of it. We're not using that, right? We need stress block, right? So what does the Whitney stress block look like? Does it look like me? Round, some sticky hair coming out? Certainly not, right? What's the word? We need stress what? Block. So it has to be a rectangular, has to be a block, right? What are the features of a block? And of course, it's not in your phone again. What are the features of your block? It has a width and it has a height. Is that right? What is the width of that block? 0.85 F prime C. That's good. How about the height? What do we call it? You gotta have a symbol, has a letter A, B, C, D, right? Which letter? A, right? Has to be A, right? And then there's another letter, it's called C, right? What is A anyway? So-called effective compressive zone. Is that right? Effective. Now, what is letter C? I don't know. Actual compressive zone size, right? What is the relationship between A and C? A equal to what? C beta 1. Almost, right? C equal to A over beta 1. That's right. So what is beta 1? Some coefficient, right? So when concrete strength is lower than 4 KSI, what is your beta 1? 0.85. What if I have a concrete strength higher than 8 KSI? What? 0.65. What happens in between? You do linear interpolation. So for linear interpolation, you need to have a step, right? You go with a slope, right? What is that slope? 2 KSI over 0.2. Is that right? So 2 KSI divided by 0.2, what do you get? Per. So every 0.1 is 1 KSI, isn't it? That's how you add up. So you know that every 0.1 of increment is 1, right? Then if I have a concrete strength of 4 KSI, that is 0.85. What is, I have a concrete strength 5 KSI, what is my beta 1? You drop 0.1, what you have? 0.85 minus 0.1, what you have? 1.75. How about 6 KSI? 0.65. Is that right? I think I messed up there. Anyway, there is the equation for it. Okay. Now, before we go there, we have now get the actual compressive zone, which is C. We got effective compressive zone A, right? What is the compression force now? Let's finish the Whitney stress block. 0.85 F prime C A. What am I missing here? Anybody? 0.85 F prime C A. What am I missing here? B. What is B? The width of the section, right? Now you have the compression 0.85 prime CAB, have the tension, which is ASFY. They have to equal to each other, right? That's how you find A, how you find C, and how you check the strain in the steel to make sure that it has yielded. But more importantly, there's a funny character. It's called strength reduction factor phi, which is a function of epsilon S or epsilon T. Epsilon T. What is the difference between epsilon S and epsilon T? Epsilon S is strain of the center of the group of bars. Epsilon T is the strain of the bar at the bottom layer, the most stretched layer. Is that right? So now you get it. What is the equation for phi? Now I forgot about beta 1. It doesn't matter, simple thing, but I can now forget for phi, right? Phi is important. So what is phi? 0.65 plus the strain in the steel, which is epsilon T, minus what? 0.00 what? 2 multiplied by a slope. And that slope, ladies and gentlemen, 250 over 3, right? That's how you find the phi. So now you have phi, right? You need to go back and find Mn, which is the moment. Two things in any moment or any coupled force, right? When we say coupled force, it has to be a force multiplied distance between the compression and tension. Is that right? Knowing that a section has a depth of ds, all right, not dt, ds, okay? What is the distance between compression and tension? Should I start? ds minus something, minus what? A over 2. There you go. So you got a distance. And now what is Mn? Mn equal to ASFY multiplied by ds minus A over 2. And you got a phi, you multiply in front of Mn, you got what? So-called design strength. Is that it? That is literally it. We will do this again, at the very beginning of the lecture till first midterm, okay? And you will get that into your zigzag shapes or your brain matter, and also copy it down on your crib sheet, and you will know by heart. That's how we solve problem in the Flash, okay? Got it? All right, so that's what we learned. All right, so now theory is out, practice. Now, what did we learn last time in terms of the practice? I don't know, Bob. I came here, you blah, blah, you bombed it, and I went home. I don't know. Well, you go back, take a look at the lecture notes, right? We did 2 problems, isn't it? 2 examples. First example was a section of 20-inch height, 12-inch width. We add 4 number 9 bars in it, isn't it? And then we said, okay, we got some moment capacity, right? 240, some 230s, I can't remember, some number, right? And then we add 2 more bars in it, make it 6 bars, right? So we learned one thing, by adding more bars, we're talking about 50% more cost, right? How much of a capacity you gain by adding those 2 more bars? Almost nothing, isn't it? Almost nothing. Now, what is the reason for that? What is the reason for that? Have you thought about it? What's the reason for that? Is it because that steel is not being fully utilized? You betcha, right? It's not fully utilized. Why? Because the strain in the steel are not high enough. So what happened? The centroid between the tension and compression got shortened. You got a smaller distance actually between the compression and tension. Although the tension force is the same, because we say that after adding 6 bars, they are approaching a yielding point, isn't it? 0.0019, right? Close to 0.0207, right? By iteration, it's something like that, just a passing yielding point. That means the tension force remains, but the distance between the compression and tension got shortened. So you end up with a less moment than you expected. Is that right? Is that right? So now you know the problem. Imagine you or me, fresh out of college, you know, have car payment, house payment, beautiful wife, have to woo, right? Where I get my money, right? I got to go out there and make some dough for myself, right? I go on a job site, I see a guy, he gave me a section, say, look, Bob, this is a section the city engineer gave me with, and we got to construct the thing, pour the concrete, get everything done. I do a quick check in my heart, realize at the moment is just not enough. What do I do? What do I do? I increase the height. You spoiled it, but you know the answer, right? We increase the height. Why? Because first of all, we cannot increase the concrete grade anymore. That's already done. All right, you cannot, Colorado already mix this into another batch of concrete. Second of all, you cannot change more reinforcement. Of course, cannot go lower, right? You have to add more, right? But we saw that adding more reinforcement is not gonna help you, right? So you can change 2 things or 2 options. One is to increase the distance between the compression and tension, is that right? By lowering the bar position, let it have more lever arm. Or you like he suggested, we have to increase the height of the section. But you're on the job site, you're in the bind here. Can you tell the civil engineer to go do something with yourself and then change the whole design yourself? Can you do that? You cannot. Why is that? It's too late, right? How much time is it going to take, right? So what you do, you reduce what? Concrete cover. You reduce concrete cover, okay? But we'll talk about it. There are limits in terms of reducing concrete cover. If the concrete cover is too thin, what happens? The water will go to your rebar and eat your rebar up in 10 years, and you don't have a bridge anymore, okay? So got to be careful there, all right? There's another thing we can do is what? To reduce the spacing between the first row and the second row, and also adding more reinforcement to it simultaneously, right? But can you just do that? You also got to be careful. Why? Because you have to make sure the aggregates, the rocks, can flow through the bars. Is that right? You don't want to have honeycombs. You don't want to have air pockets inside your sections, right? So there are also limitations to do that. So you have some things at your disposal you can manipulate, but there also are limits. And that, my friend, is how you make your car payment or house payment. Is that right? Okay, get it? Okay, so I want you to understand what we're doing here. Now simply just use equations. Anybody can plug in equations. My kids, or I don't have kids yet, but my future kids can do it in high school, right? But I'm not expecting you guys to do that, all right? Don't plug in equations only. Understand what you're doing with here, okay? All right, so good point. Now let's continue. We know now we have a predicament. We cannot increase the capacity by throwing more reinforcements. All right, so today I'm gonna use a slow pace, okay? I'm gonna run a funny competition today. Yay, first time ever. Bob's now one-way output. Now I get to say something. You're right, you get to say something. I need 4 groups now from the class today, 4 groups. Okay, you develop among yourself, okay? I don't care. Find your partners, whoever you want to work with, 4 groups, okay? I give you 5 minutes to do that. And we're gonna have a competition, okay? And I will not reveal the purpose of the competition just yet, but I need to have 4 groups, okay? So from now, which is like 20, let's wait till 26, is 21 now, to have 5 minutes for you guys to group yourself, okay? Find the strong guys you like to work with, okay? This is just like the Squid Game, okay? Find a good, I mean, there are rewards and also, I'm not saying punishment, but relatively it's gonna be a punishment, right? Rewards involved inside this competition, okay? All right, so let's go. All right, 4 groups, no more, no less, 4 groups only, okay? 4 groups. Convenience, geographic, whatever, you know, find your partners. Okay, we'll have more competition down the road. So if you find one, stick with it. Okay, find one group, stick with it. Come on, find groups. Okay, every group you will have a captain come explain your design and everything. You also have some people doing the calculation, right? You gotta have a leader. You gotta have a guy do the work. You also have to have a guy know how to present. You know the story behind it. Alicia, in case you don't have a group, you can just be on your own for now, but don't worry about it, okay? I will find you a group to join later.
Okay, that's fine.
Okay. Okay. All right. Do we have 4 groups now? Still need more time? Okay, so let's do this. Let's go with group 1. Okay. All right, so you guys have a group now? Okay, what's your group's name? Gotta have a name, man. I mean, most important part, what do you want to call yourself? So again? That's the latest name. But anyway, whatever works for you. How about the group behind you? Anybody?
Yeah, with the unicorns.
Unicorn, I like that. That's a good one. I'm horrible in spell. Help me out. Make sense? Okay, nice. How about you guys here?
Zebras.
All right, sounds good. I know zebra.
I'm a horn and you don't.
How about the team at the end? Anything?
Bob the Builder.
All right. Yeah. You know, this is actually not the first time I've heard this team name. Anyway. All right, good deal. Okay. So this is our groups. This is a contract bidding game. All right. That's not, we have a contract here. I have talked to the MODA. We're gonna have a bridge soon. Okay. Perhaps on I-94. All right. Unfortunately, that real project has been bidded, but let's do it again all over again. Okay. Now for this I-24, I have some constraints. All right. These are the constraints. I'm gonna write down my notes so at least you can see what we're doing here. Okay. But these are the constraints. So today, this is more like a quiz or competition. So I'm just gonna say quiz/competition. And Alicia, you might just be your own for now. Just try to write or solve the problem as much as you can do, okay? But don't worry, I will assign you as a different group. Okay, so quiz and competition. Today we have a section. Okay, given a section that is a B equal to 12-inch, width is set, okay? And height has ranges, H equal to 20 to 24 inches. It cannot be smaller than 20 cannot be higher than 24 inches. Okay, and I have a number 9 bars at your disposal. Number 9 bars at your disposal. And I say that you have choices of making how many number 9 bars you have in the section. So let's say ranges to 4 to 8 bars in the section. Okay, and I'm going to give you some constraints. Since I'm going to order the concrete from Rolla Ready Mix with 3/4 aggregate size, so that every bar, if you want to put in the beam, has to be clear spacing 1 inch apart. That means in all directions. We'll talk about it later, but these are the constraints you need to know for now. 1 inch of clear spacing. Okay, so my aggregates can flow through. All right, and I need to have a minimum of concrete cover. Minimum of concrete cover of 1.5 inch. And for this, let me draw a drawing. I'm talking about at side clear spacing 1.5, the bottom clear spacing 1.5. Okay, be careful, okay? Be careful, okay? Why be careful? That is clear spacing between the edge of the bottom bars to the bottom side of the concrete, right? So when you calculate depths, it is not h minus 1.5. Do you get it? You have to count for the centroid, right? You have to count for the dB divided by 2 bar size, right? Be careful of that, okay? I'm just wanting to know that. I'm not trying to trick you. I'm just providing my constraints, okay? Now, these are my constraints. And concrete is decided F prime C, 4 KSI, and yield strength of 60 KSI, grade 60, making it easy for you, okay? Grade 60. Okay. Now, the bid is this way. This is the problem, right? So problem. Okay. And the bid or the cost is this way. Each number 9 bar will cost you $1. Okay. Each number 9 bar will cost you $1. And in terms of cross section of the concrete, right? In terms of cross section of concrete. So concrete, each area, 1 inch of area costs you about $0.25. Okay, that's a quarter. Okay, say if you have 12 by 20, that's what, 240. So multiply by quarter, that's $60. All right, you know how to do calc, right? That's $60. Now I want a bid, only one. All right, I only want one bid. I have $250 million. Okay, but of course, unfortunately for this project, it's only $25. I don't know, but I have this much money, and in reality, it is the case. Only one of you guys will survive. Get the money, feed your kids, buy nice cars, buy beautiful houses. The rest of the 3 go hungry. Okay, this is real. Okay, this is real. So I have one bid opening up, and my criterion are 2. Okay, of course, first thing, has to have the highest design capacity. Have to have the highest design capacity within my confine of the parameters. Second, of course, lowest cost. Okay, lowest cost. All right, so these are my bid. Is that clear? Is that clear? Okay, so right now it's 9:26. We'll probably start in 2 minutes, right? Okay, and I will give you guys about 15 minutes, something like that, to finish and wrap up and talk about it. But before you do that, there are certain rules for the bid. Important rules for the bid. Okay, okay. Now, the first team present me the bid. The first team presented me the bid. So first team, give me the number basically. How much is the cost? What is design capacity, right? Come right, rush to the board, write it down, okay? Write it down there. First team, I will give a $5 discount. -5. If you're first, I'll reduce your cost by $5 because you guys are fast. I cannot wait longer, all right? I need to get it done. And that's reality because government is giving us so much money, right? We need to get it built. I cannot wait, so $5. Second, the number you presented best be right. Okay, you tell me this is how much it costs, right? You tell me this is my design capacity. It better be right. You cannot fool me, right? And I'm lazy. I'm the financier, right? I don't know how you guys call it in the casino business. I'm the host, right? So I'm not gonna do any hard work. I will let you guys to inspect each other. Okay. For example, if team one, group one, come in here and set some number, and unicorn for some reason said, oh, there's a mistake there. Okay, but it has to be valid. Okay. If anybody has any problem with their number inspections, and that team will get a $5 discount. Unfortunately, the first one will get a penalty of $10 added to it. That means you think you're first, right? Come here, rush into the board, write some number down. I want to get $5. Unfortunately, the other team said, no, you have some problem. Then instead of getting a -5, you get a $10 increase on your bid. And the other team who spotted whistleblower get a reward of -$5. All right. Yes, you will sabotage each other. That's my favorite game here. Okay. I am not going to do anything. All right. I'm just going to quietly watch it and see who's going to get my money, right? Who's going to win this situation? All right. So that's what I'm going to do with this. Okay. So that is all you need to know for this game. All right. The time is now 28 on the spot. So you have 15 minutes to start. Okay. So start now. The width is fixed. B equal to 12 cannot be changed. Okay. Concrete is 4 KSI, still 60 KSI. Okay. Alicia, you can just pick a number on your section. You don't have to do optimization because you're only yourself. So just give me some number and later I can combine that with any team you want to join later. Okay. No pressure. All right. Thanks. You guys have to have one captain, okay? The captain will present, yes? The concrete, right, is a section minus the rebar area, right? Concrete minus the rebar, right? It's getting good. You get to draw your design as well, okay? You get to draw your design as well.
Yeah, I think this
You can't do 5 bars. The area is 0.5 plus 0.5.
Give me like 1.5. Or no, so we split.
Five minutes has passed, okay? Gotta wrap up the design quickly, start do calc, okay? You need time for calculations, all right? If you haven't decided your design quickly, okay? Determine it, start do calculation. We'll run out of time if you don't do that, okay?
You got something different? Oh.
Okay, so we don't have.
And now we gotta calculate.
And so are they?
I'm gonna. Also have a higher height section.
I was just, do you think that works? Just to run a kind of details. Yeah. So maybe where you don't mind right calculation that she had.
Six more minutes left. That $5, it's pretty interesting, right? $5 reward is pretty significant. Okay? If you got a number, you can come up here, rush into it. Be careful, okay? Be careful.
Yeah. I was like, where's the rest? Not sure which one. So our ACS.
So that's $75. We have 3. You give about 3. Yeah, we can still keep that. We find a better.
That's you. We just have to change it.
You mean- Yeah, let's put that in. Are you? I don't want to.
Yeah.
You want to? You get closer.
That's greater than.
You know, so it'll be 4. Then it should be on 4. Yeah, man, I say oh, we win. Hey, which one are we? Zebras?
Don't worry, okay? Look closely. They might have mistakes, okay? We don't know. They may have mistakes, okay? We don't know.
Oh, yeah.
Draw your design, please. Like put a figure there. Just
Oh.
yeah. I need to know the section design, right? That's what I'm paying for.
It doesn't matter.
Bar size number 9, right? Just label it. And you need to have a distance like between the top and bottom, like depth of it or whatever. I need to know location of the bar. Right. Is it 1.5? Put it at 1.5. It's fine. That's all right. That's okay. As long as I know how to put the bar, then fine. 1.5. Okay.
That's the edge. Spacing one.
Don't worry about it. I got it. Thanks. Great. Okay. One team have a solution now. All right. Thank you. Two more minutes, okay? 2 more minutes. And then you have to come up here. Okay? 2 more minutes. Everybody has to come up here.
So we order one for bar.
All right, 43, time's up. Everybody, any other team, come just write it up. Whatever you have, that's fine. Find somebody and write it up, please.
Okay. How much is it?
There's a black marker there. Anybody got anything? Here, try to use this one. Yeah, see if that works. I have one before. Only have the red one now.
Oh, I'm on his team. I was just coming to talk to him.
Does it work at all?
This one's not working.
Okay, let me see. I'll be back in.
Sometimes give it the requirement for additional That was good.
I run this.
Like what combination? You got 20 inches or.
The one that we did. We wanted this cheaper than that. We should have drawn it on the paper and gave it out.
You guys all have the same one? That's exactly what we got. Yeah.
Yeah, I'm not a great.
Right? Yeah.
What was this one? This was 20 inch height with 4 bars. Because of those things. Yeah, that's right.
Oh.
So maybe
If you're done with your team, look at other teams design, right? Find some problems. First thing to start is the bidding. That's always the easiest mistake they can make. Okay. And find some problem, right? That's $10 for you. Sorry, that's $5 for you. $10 for the others. Okay. So box this out. And,
I think their cost is lower.
which one?
Do I need to put anything else
This one?
on this?
Yeah,
Okay, how much you think it is?
it should be 63.
63, right?
Oh, I had 63.
Oh, so is there.
Is that right?
No.
Is that right? I'm gonna leave it here. Okay, you guys be the judge.
Yeah, group one.
6'3" as well. What's your team? Zebra? 63 or 63? Anybody want to sabotage more? We still got a few more minutes. Anybody? Anybody? Let's do a quick check, right? Bidding is always the easiest one to make you say something. Okay? Now find a number. You got to go through the hoop, right? You don't want to do everybody's work, right? Anyone? No more sabotaging? We're all happy? Okay. All right. So let's start with group one. First, 264 kips. That's rather low, but is this calculation right? Anybody have issue with? Yeah, how many bars? 4 of 9 bars, 20 inches. Okay. I think that's the configuration they end up with. Any problem with the calculation? Not really. I don't have a problem either. I checked this number and this number, and the other number is pretty close. 264, 266, that's around same number, okay? Round up and everything, okay? This is good calculation. Now this number is wrong. The bidding has some problem, isn't it? Did you check it?
They want to make progress.
Okay, well, sure. Let's do a check, right? So this is what? 240, right? Minus 1, 2, 3, 4. So 236, right? So let's do it. 236 multiplied by 0.25. That is what? 236 divided by 4. 59, is that right? 59, right? Plus the 4 bars back. That's what? 63, right? So that is wrong. Okay. So Zebra get a minus $5, right? That's pretty good reward. Okay, and penalty plus $10. So what we end up with? Use their old number, okay? 64 plus 10, $74. That's pretty bad, okay? That's pretty bad. Not looking good. All right, so unicorn. First of all, is this bidding right? $75? Yeah, I checked myself, pretty good, okay? How about the capacity? The capacity okay? Yes, right, the capacity is okay. Why is it okay? Because they utilize the highest, but they're not greedy. They only put 4. How many bars you put there? 4, right? So they're not greedy. They only put 4 bars here, which is good. Because if they put more bars, the compressor is only going to change. They end up with a shorter distance. So that's smart. Okay, so this is okay, right? This is okay. Yeah. So now this one, nobody gave any problem with. So I'm going to say $75 with right now the highest capacity. Okay, right now, currently. Okay. Third group, Zebra. $75 bid, same configuration as the Unicore. I don't know who copied whom, but you know, I know, just kidding. Yeah, I'm just kidding. All right, all right, all right. So now they look identical, right? And number 9 bar, 4 number 9, pretty good design. And I think this is the optimum design. Okay, I did it myself, pretty close. Okay, the correct answer should be number 5, number 4 bars, but then you're running into the issue of whether you can fit it in or not. But that's okay. So this is good, $75, and they have a $5 ahead. They come out first, right? So $70 a bid with the capacity 342. Okay. Oh, you got 5 there even. All right, that's even better. So 5, so that's 65. Almost forgot. Good deal. So that is very good. Okay. So how about the last one? Is this bid right? 64? No, $1 off, right? So now the capacity is the same, or more or less the same as the other one, right? 4 kips are different, but that's okay. Then again, they make 4 number stand this way. And I think that's the problem with that, right? If you space them up, you have a shorter distance between the centroid of tension, centroid compression. That's a little bit unfortunate. So that's where the 4 kips, the difference coming from. But that's not a problem. The real problem is the bidding error, right? So that's adding a $10. So adding 10. And now that's sending $4 a bid. And this is group 1 and says something wrong. So group 1 get a -5, right? So go back to group 1. So you know, it's 69, right? So sabotaging sometimes works, right? Unfortunately, morally not a good thing, but sabotaging sometimes works, right? Actually, what's really going behind, you have to check the numbers. So at the same time, check other people's as well, right? To make sure everything works. That's how we keep the balance. That's why how we keep the balance, right? So, okay. So who win the bid?
And we do.
Zebra, right? All right. You take home the dough. And you take home the reward. The reward is 10 points to everybody on the group. Congratulations. Okay, 10 points. All right, let's give them a round of applause. That's a significant number. Come on, guys. It's okay. But in reality is that this course has about 1,000 points. Okay, so 10 points. All right. So before I let you go, 1 second. What did we learn from this?
And that we're smart.
What did we learn from this? Increase your height. Don't be too greedy with the reinforcement. Make sure you have the highest distance between the compression and tension. And that's how you win the game. All right, got it? Okay, thank you very much. I'll see you guys on Thursday. Okay, Thursday. See you guys on Thursday. Alicia, we're done. And I will post the separate notes about uploading the work. Okay, and see you on Thursday. Thank you.
Okay, thank you.